Hello, my name is Rafael and I'm in Group Gigabytes and I'll be presenting the final design of our circuit. So if we connect it to the computer, we can prove that it's working and it's accurate by comparing to the actual thermometer that I have over here. So as we can see, we are in about 21.6 degrees Celsius. So that is indeed what we are getting, 21.6, 21.5 um, values, and we can actually confirm that it is what we should be getting by, for example, looking at the um, digital units that it's printing out on the code of the Arduino. So here I should be getting live feedback. I'm not, so I'm gonna run the code again because I just plugged it in. And I should be getting live feedback. So for example, let's calculate it first. At 21.8 degrees it is now, actually, it just changed. So 21.8 degrees, we should be getting around 444 digital units. So if we go into the serial monitor of the Arduino, we can see that we're getting live feedback right now, and we're getting around 444, 446 digital units. And we can compare it that we are actually in that ballpark. It should be between them two, so we're actually getting the same values. And if we look at the thermometer again, we're getting 21 yeah, it's jumping around a little bit. And then here's the proof. So now we can connect it to the power supply. Here we have 4 AA batteries, which are 1.5 volt each. That makes it 6 volts. We decided to go with 6 volts because we read online that Arduino is not a fan of 9 volt batteries. So we connected into the VN of the Arduino Nano and the ground. And if we turn it on, it should be working just fine like it was before. When it boots up, we should be getting around 21.9 degrees, and we're indeed getting 21.8, 21.9 degrees Celsius. So for example, if we put our thermistor into the body temperature, kinda, well, it won't get up to the body temperature exactly, but we can see that it's rising up to 32 degrees and all. And if I let go, it's gonna go down slowly back to room temperature again. So the bridge is actually here. We have a series of potentiometers just to get the bridge balanced very well. So as we can see that it's actually working smoothly. So I found another thermometer here. It's a bit more sophisticated because it's used for measuring your body temperature, and it's using an ultraviolet light to measure it. Well, now it's not gonna measure anything because we're in the body temperature setting, but as we can see here, we have two settings. We have the room temperature, so it measures actually the room temperature and the body temperature. So I'm gonna showcase that as well. So yeah, we have it set to body temperature right now, and let's see. So I'm 35, you can't really see because it's flipped, but it's 35.8 degrees. Well, my body is 25.8. So we're looking at a very accurate thermometer here. Still 25.8. So yeah, as we can see, we can change it to room temperature now. And we can, for example, test this over here. 22.3. Okay, let's try and get the temperature reading from our thermistor here. It's up in the air, so it could be a bit colder. It's 21.4 degrees, which is very close. We're off by 0.3 of a degree. which is an absolute win in my books. So we said that we want around 2.13 volts out of the differential op amp, and I'm looking into the analog in of the Arduino and the ground. So I'm getting around 2.17 volts, which is very close. We are very accurate here. And we're still using a 6-volt power pack. So yeah, I think we're very, very accurate here.